Today we're going to learn about how there's more science happening in your everyday life than you may realize. It's summertime and you're camping. While sitting next to a campfire, you're thinking, what kind of summertime treat can be cooked over a campfire? A s'more, of course. Take a soft, fluffy, white marshmallow and roast it over a bonfire for a minute or two. Watch it turn crispy and golden brown on the outside and warm and gooey on the inside. Then place the roasted marshmallow in between 2 graham crackers with a piece of chocolate and you have a delicious s'more. S'mores are just as fun to make as they are to eat. But did you ever wonder what makes the soft, fluffy, white marshmallow turn golden brown and crispy on the outside with a warm, gooey center? Let's take a closer look at marshmallows and why they brown, crisp, melt, and expand to create the perfect filling for a delicious treat, leaving you wanting s'more. Going back in history, marshmallows have been eaten for thousands of years, starting during ancient Egyptian times when they were saved as a special treat for royal leaders and gods. But the marshmallows eaten back then were a lot different than the soft, fluffy ones we eat today. Honey and sweet sap from a mallow plant that grows in marshlands were mixed together and boiled to make the first marshmallows that had a very hard texture. Since a main ingredient was from a mallow plant that grows in marshlands, they decided to call their treat the marshmallow, which is where we get the name for the sweet, fluffy white treat that we eat today. But today, instead of boiling mallow sap and honey, we whip together sugar, water, and gelatin to make the marshmallow soft and fluffy. Each ingredient plays a different role in making the soft, fluffy marshmallows that taste so great. The sugar provides the sweet taste to the marshmallow and makes up the largest part of the recipe. The water helps dissolve the dry ingredients so that they can be more evenly mixed and interact with each other. The air is added to the liquid mix by whipping it with a whisk. The gelatin is a type of protein. Proteins are like a strand of different types of beads. When they're twisted, the strand of beads comes together and forms a tightly wound ball. When they are untwisted, they return to the simple strand. This is called protein denaturation. The gelatin protein in the marshmallow is responsible for holding the air in the mixture once it's whisked in. It does this by wrapping its unwound strand around the air bubbles, like a snake wrapped around a ball. This prevents the air from escaping the mix. When making marshmallows, the air bubbles get trapped in the gelatin, and those trapped air bubbles are what makes the marshmallows so light and fluffy. But what makes those white, fluffy marshmallows crisp and brown? It's the addition of heat from the campfire. This heat causes chemical reactions to occur in the marshmallow, changing its color, texture, and flavor. In the presence of heat, sugar and proteins in the marshmallow undergo a reaction called the Maillard reaction, giving it new color and flavor. Then, with additional heat, a second reaction called caramelization occurs, where sugars interact together to also form new colors and flavors. Both of these reactions give the marshmallow its golden brown color and toasty flavor. The chemistry going on inside the marshmallow is like building things with Legos, where the uncooked fluffy white marshmallow is like a Lego tower. The red Legos represent sugar molecules, and the blue Legos represent protein molecules. Depending on how you combine them, you can build different Lego towers, like making marshmallows with different colors and flavors. Now that we have a crispy brown marshmallow on the outside, let's take a look at what's going on the inside to make it grow when you roast it on the campfire. When the water and air molecules are exposed to heat from the campfire, they heat up and begin to move around quickly. In the marshmallows, the air trapped inside the marshmallow by the protein will move quickly around and bump into the crust, expanding the shape of the marshmallow. It's crazy how much science is going on while making a simple summertime treat. But no matter how you prefer your marshmallows, soft and fluffy or golden brown and crispy, we hope you learned a little s'more about food science today. And remember, when doing cool science experiments, always do them with an adult. If you want to recreate this demonstration at home to see protein denaturation in action, follow these guidelines for making marshmallows. If you want to see the Maillard reaction and caramelization in action, follow these guidelines for roasting a marshmallow and making a s'more.